expand, and we're going to be talking about differentiability. Cool? The two main things that we're trying to prove today is whether continuity implies differentiability or vice versa. Does differentiability imply continuity? Those are the two main things we're trying to prove. And what we're going to do is we're actually going to do non-examples so that way you can make your decision. Sounds good? What does it mean when I say something is differentiable? I can get the derivative of it. What do you mean by I can get the derivative of it? Because I can get the derivative of a function, and that gives me an equation, but that doesn't tell me if it's differentiable. What do you mean by get the derivative of it? Maybe. Those are all good answers, but I think what you're trying to get at is if something is differentiable, it means that, like you said, it has a derivative, but more than that, more specific what you mean by it has a derivative, I think, is that it has a slope, right? So it has not just a derivative equation, because I can get that for anything, but that it has an actual, when I plug in the number, I actually get a real number. I get an answer back, right? Because what would happen if I plugged in the number into the derivative formula and I got like 5 over 0? What would that mean? That's undefined, right? So that means that the slope is undefined. It means that the derivative is undefined. So does that mean that it has a derivative at that value? No. Does that mean that it's differentiable at that value? No. So that's all we're trying to prove. That something is not differentiable here because, you know, it either has a hole there, right? If it has a hole, can it be differentiable? No, because I can't even find the derivative at that value, because there's no value there. Or if it has, what does it have if the derivative is undefined? What kind of a tangent line will there be? A vertical tangent line, right? Because the slope of a vertical line is what? Undefined. Okay, so remember that. That's all we're trying to prove, and that's basically the simple way of explaining it. I'm going to make it so much more complicated, you're going to hate me, but it's okay, you right? We're just going to kind of explore things, and we're going to talk about things today, and then tomorrow we'll get into the nitty-gritty of actually proving whether something is differentiable or not. Today we're just going to have visualizations of when something is or is not differentiable, and why. And tomorrow we'll actually do the mathematical way of proving that it is or is not differentiable. Sounds good? Yes? Alright, so let's do some exploration, okay? And the two main things that we're trying to show is if a function is continuous at a value, does it imply that it's also differentiable? That's one of the things we're trying to prove. The other is, if a function is differentiable, does that mean that it must be continuous? We're trying to see if both of those are true or if only one of those is true. Does differentiability imply continuity, or does continuity imply differentiability, or is it both of them? Okay, so that's what we're going to try to prove by exploring and seeing different examples and talking about them and all this fun stuff. Sounds good? Alright, so we're going to start off with this function. It's kind of something weird, something you usually don't see. The square root of x squared minus 4. Okay, so it kind of looks like the square root function, but it's like two square root functions. Okay, so one of them is going to be at positive 2 and open this way, and the other one's going to be at negative 2 and open that way. Sounds cool? It's kind of like a longhorn, except you got to put the head in the middle. Am I in the middle?
Yeah.
Yeah? Do you see my horns? Yes. Alright, so anyways. So, we got this function. Let me just ask you a random question, okay? Would you say that it's continuous at 2? Just by looking at it. Don't do any math. Don't do any check with the three things of continuity. Just look at it and tell me. Would you say that it's continuous here?
No.
Yes,
No?
because there's no hole.
Or yes? So Gabriel says yes because there's no hole. Those of you that say no, why not? Do not do any check based off of the rule of continuity. Just look at it.
Yes, it is. There is no left side.
So let's say you didn't know. Let's say you didn't know calculus, and I said, okay, is it continuous at that number? What would you say?
What's continuous?
Wouldn't you just say yes?
Yeah.
Yeah, it's continuous. Why? Why not? Right? Okay. So there is an argument as to whether it's continuous at that because it's an endpoint. Okay. But that's not what we call the gray area in mathematics. Some mathematicians believe that it is. Some mathematicians believe that it isn't. Okay, the person that wrote our math book, our calculus book, is a math purist. So to him, this would not be continuous, but to other people, it would. All right, and we're going to talk about that discussion in a little bit. But we're going to use the three-part definition of continuity to see if it is or it isn't. Okay, so let's use that definition now to answer this first question. Based on the graph, is it continuous at 2? You said what? You said no. Some of you said no because you started using your calculus. So no because. Tell me why. Which of the three parts does it fail? The limit does not exist. Okay, so show me that. So the first thing is it must be defined. So f of 2, what do I get when I plug in 2? 0. Okay, so the function is defined. The second thing is that the limit must exist. For the limit to exist according to mathematical purists is that the limit from the left must equal the limit from the right. So let's see that. What is the limit as we approach 2 from the left? Can I approach this graph from the left here? No, so what would we say the limit is? Does not exist. Remember, limits exist or do not exist. They're not defined. Okay, what would be the limit as x approaches 2 from the right? That's 0, right? As I come along the graph this way, I'm getting closer and closer to 0. Okay, so what does that mean? The limit from the left, did it equal the limit from the right? No. So therefore, the limit as x approaches 2 from both sides, we have to say does not exist, right? So since it failed that second part, we can say that the function is what? Not continuous at x equals 2. But when we looked at it, and if we looked at it with an open mind, and we said, no, I don't know any calculus, I don't know anything. I'm just thinking of what the definition of continuity means, right? Something is continuous, right? And you asked me, and I would say yes. Me personally. But then when I do the calculus, it says what? No. So what's the deal? What's going on? It's an interesting conversation, okay? And when we finish this problem, we'll talk about the gray area and the other point of view that other mathematicians have based on it. Okay? But for our sake, we're going to go off of the purest point of view. So it has to pass all of these tests, or else it's not continuous. For the AP test as well. Cool? Alright, second question I'm going to ask you is, what kind of a point is this? What can we call this? This is an endpoint, right? Okay, the next question is asking us, find the value of f prime of 2 to determine if f of x is differentiable at 2. Okay, so for it to be differentiable, it means that when I find the derivative, I better get a number. I better plug in the number into the equation, and I better get an answer. I can't get something that's undefined. But before we do that, let's think about what a derivative is. What is the derivative? The slope generator, so it's the slope of the tangent line. So let's think about the graph, and remember that first assignment that we did before coming into derivatives, where we drew a whole bunch of tangent lines. So what kind of a tangent line would I have at 2? A vertical tangent line? So what is the slope of that vertical tangent line? Undefined. So should my derivative, when I figure it out and I evaluate it, should I get something that's undefined? Yes. I can know that answer already, but I need to show the work for it. Okay, just by looking at the graph and saying that it is not enough. You understand? But I already know what my answer should be. So let's see if we can do that and get the right answer. Are we ready? Alright, so to find this, we first need the derivative. So I'm going to rewrite the function as x squared minus 4 to the what power? To the half, and now I'm going to find its derivative. So what's its derivative going to be? Let's see how good you guys are. Can anybody help me by telling me what to write? 1/2 x squared minus 4 to the negative half times 2x. So most of the times kids forget the negative half power, and they also forget the what? The 2x. If they forget this one, they usually remember that one. But if they forget this one, they usually remember that one. Okay, so you got to remember both of them, okay? Don't make that mistake on the AP test. It's the most common error. Okay, messing up on the chain rule. Alright, can we rewrite this guy, or can we cancel something out? This 2 and this divide by 2, so this ends up being what? 1x over the square root of x squared minus 4. Alright, so now that we want to find f prime of 2, so plug in the 2. That gives us 2 over the square root of 2 squared minus 4. So that's 2 over what? 0. And that means that this is what? Undefined. Oh, cool. Were we supposed to get undefined? Was the slope of the tangent line we drew undefined?
Yes.
Yes. So we did our work correctly. Okay, so what can you tell me about it being differentiable or not? It's not. Okay, so let's say that what? F of x is not differentiable at x equals 2. And we have to justify, so because what? Because f prime of 2 is undefined. And that's how we would have to write our justification statements. Okay? Not too bad? So what happened in this problem? Was it continuous? No. Was it differentiable? No. So did continuity in this case imply differentiability? Or we can't determine that yet. So this one was not continuous and it was not differentiable. So does that prove to me that if something is continuous, it is differentiable? Not necessarily, right? We need to do another example? Okay, so we'll keep looking at it. But at the bottom, I want you to write what happened here. So this was not continuous, right? And not differentiable. Specifically at what? X equals 2. Where else do you think it would be not continuous and not differentiable? At -2. Why at -2? Because it also has a vertical tangent, right? It's also a what? Endpoint. Okay? So we learned two things today. Something is not continuous at an endpoint, and something is not differentiable at an endpoint, right? Right? Or wherever I have a vertical tangent line. Very good. Cool? Do you want to talk about the gray area? Not the green area, the gray area? Regarding the topic about continuity at an endpoint? Or you're not interested?
Is it confusing?
Yeah, but if y'all want to talk about it.
You think it would be confusing? You don't want to talk about it?
No.
Maybe
God,
in the future when we become competitions.
I guess.
Good.
My gosh, I was so excited about this.
You didn't go
It's
for it.
okay.
Good.
Explain it.
I'm making us feel bad.
No, it's okay. Yeah. It's okay.
Good.
You want to do it, okay?
No,
okay, we
I'm
don't have-
interested.
The sad face.
We already done it.
Yeah, we're gonna do it anyway. The people in the other class weren't like that.
They wanted to talk
Oh, of course. That's why they're in calculus.
about, but we're not.
Oh,
I
I
bet,
know.
or there's like people that don't agree with calculus.
You don't care? What did you say?
That I'm here to learn about what people don't agree with, and I wasn't gonna say.
Oh, okay. That's all you care about. Well, anyways, let's talk about other things. In this case, the gray area, okay? So some mathematicians have an argument regarding, I spelled gray wrong?
No.
Is it gray?
We spelled it the gray
Is
one.
that an A
You
or an
spelled
E?
it gray, like, I don't know what gray it
Is
is.
that, I
Is
spelled
that a
gray.
gray?
You spelled it gray.
That's right.
It's gray spelled. That's
It's like the
It's
girl
EY.
It's EY.
No, it's AY.
No,
I
but
thought it was
like,
EY.
Is it right an A or an
It
E?
depends on what color, like.
I thought it was EY.
Oh, they're different
I thought it was
colors?
EY.
Gray with
No,
an
like
E, gray
if
with
you
an
put
E.
EY, that's the British way. If you write it
Yeah, with an
EY,
E,
then
it's
it's
from
American.
Europe.
That's
Gray.
not true, it's cause it's a name, like,
Gray.
yeah, it was like
Yeah, it's a
Grace
name.
Nam, and then there's really Grace
With an
Nam.
E is a name?
Yeah.
it's fun.
Okay, so I did okay?
yes, sir.
Thank you.
Wait, so the colors not wait.
So it's not gray with EY? It's EY?
That's
No,
AYS.
it's
Okay.
But I mean, like, as long as there's
The
consensus,
word
like,
gray
it doesn't
with-
matter.
As long as the world agrees, right? Like the election.
Yeah.
Yeah.
Wait, let's try it.